So what we want to know is how we were going to get our solutions. And one of the things we need is a new notation to write down these solutions that we're going to have. Because in the last two cases, one of them we actually had two solutions that worked. And believe it or not, there's going to be multiple more solutions. So we need to write a new notation that's going to help us with multiple solutions. So set notation is a way to represent sets as equations or inequalities, or sorry, a set of solutions to a equation or inequality. Usually what this is going to do is it's going to avoid listing out solutions and have other ways to write this, but sometimes we still write the list. So the equation 3x squared minus 8 equal, or minus 1 equals 8 has two solutions. X equals -1 and x equals 1 are actually both solutions to that. In set builder notation, we would write this x, this bar, x is equal to -1 and 1. Seems like a bunch of extra work, but set builder notation, we use more complicated solutions later on. So set builder notation first knows the variable in the first part. That is what this part is telling me. It's what my variable is. My variable is going to be an x. So that is what I'm looking for solutions to, is to x. Then this bar here, that means such that. So what we have is a variable. We're trying to figure out what that variable is. There is a variable such that a variable is going to be equal, or it's going to be somehow described here about what it is. We have the variable and then such that and the description of that variable. In this case, there exists an x. That's my variable, such that x is going to be equal to -1 or 1. So that is my descriptor right here. So we don't use this just to write out a list of solutions. Other things it can be used for is other examples of set builder notation. There's an x, but the x has to be less than 4. Or there's an x such that x is a real number. This means an element of the real numbers, or you can say x is just a real number. So it can also be a way of just describing what your number is. And when you have a case where you cannot write a list of solutions. So I can't write a list of solutions here because not only does 3 work and 2 work and 1 work, but everything in between 3 and 2 and 1 and 2, all of those numbers are also solutions, and I can't write them all out. That's what step builder is good for, is when you can't write a list of solutions. So the graph of an inequality is a visual representation of an inequality solution set. An inequality in one variable can be graphed on a number line. So the graph of x is less than 2 on the number line would look like this. So here's my number line, and x, well, x could be 1, it could be 0, it could be -1, but as long as it's less than 2. So we make sure that we get that starting at 2, and we just record everything that is less than 2. We're going to talk about that little notation there as well. So sometimes what we do is we'd actually write just an open circle because one of the things it can't be is 2. Note that in set builder notation, we would just write this as x is equal, or there's an x such that x is less than 2. We need something called interval notation. So interval notation is a way that we can write solutions to inequalities. So another way to write a solution for an inequality in one variable is to use what we call interval notation. Interval notation uses parentheses and brackets to symbolize what kind of inequalities that we have. And what we have here is, go back to the next page, is we have what we call open and closed points. When we have a strictly less than or greater than. What this means is that I can get really, really close to 2, but I'm never going to equal 2. What happens is, like I said, we get close to 2. We actually get infinitely close. So we get infinitely close to 2, but never reach it. So what we use this open circle to represent the fact that I'm never going to touch that point. So what we have here is what we call an open point. Like I said, so if we get infinitely closer and closer to, but we never reach it, we put an empty point there. So I know a lot of people have seen this. I just want to kind of briefly go over that again. Let me put a little slight little change here. So let's say we have this equality. So we have the case of something is less than or equal to or greater than or equal to. What this means is that we're going to actually touch 2. So we have everything less than 2. And we actually reach 2 as well. So to signify that we actually touch that 2, we put a closed point there. Like I said, I know some people have seen this notation, some people not. Just want to briefly go through that. So going back here, make a little chart here. If we have strictly less than or greater than, we use what we call an open point. We say it's open. But also what we're going to use, as we see here, if A and B are real numbers such that A is less than B, then we define the open interval AB as a set of all numbers in which X is just going to be strictly less than B and strictly greater than A. When we have an open point or we have this symbol, that's when we're going to use parentheses. So this is what we call, like I said, an open interval. So an open interval means that both ends are going to be open. So there's an open point at both ends. A closed interval is the case, is defined as a set for which all numbers are going to be less than or equal to B or greater than or equal to A. So we have that equality. And when we have that equality symbol, that means that we'd have what we call that closed point. That's why we call this a closed interval. So we would represent this with brackets. When you're talking about the actual number line, sometimes they're going to write those bracket symbols like we have here. Or sometimes you might actually see the actual point put on there. So when we move into actually like graphs of equations, you're going to see those points opposed to these brackets and these parentheses. Same thing here. This is the graphical representation of this inequality of x's between A and B. So sometimes we graph this with open points there, or sometimes we just use the parentheses. Okay. So we have your open interval. You have your open interval like this. So if we have an equality that looks like this, then this is how we write the interval. If our inequality includes that with equal signs like we do here, then this is what our interval notation is going to look like. We're going to use those brackets. So what we have here is the first side interval notation. And then the side here is going to be what we call the inequality. So we can have intervals that are open and closed, like open on one end and closed on the other, or vice versa. We call these half open intervals. So if we have a number that is less than or equal to b, but strictly greater than a, then what you notice here is that because we have this equality, and it's strictly less than here, you're going to use a parenthesis on this side. And then because you have that equals part into this one, you're going to use a bracket on this end. So what we have here is that if a or x is strictly greater than a, then we're going to write our interval as parentheses a to represent that strict inequality there. And on the other side, x is less than or equal to b, we're going to use parentheses to signify that that is going to be an inclusion there. So that is a equality involved. Move my whole slide up here a little bit. The same thing down here. If x is going to be greater than or equal to a, then we're going to use a bracket on that end. But x is strictly less than b, we use a parenthesis on that end. There's also the case that we have was like a one-sided inequality. So we use the symbols, which are we call our infinity symbols. This is positive infinity. And this side is negative infinity. But we use these infinity symbols to represent, like I said, positive and negative infinities, respectively. Thus the notation a, so parentheses a, infinity parentheses, represents a set of all numbers that are strictly greater than a. We have some sort of x's that have to definitely be greater than a because we need to have them at a and everything greater than that. If you start with the negative infinity first, well, what that's saying is that we're looking at everything that is less than a. So that is all my values of a less than x that are less than a. So the notations of negative infinity is equal to a and bracket a and bracket a is equal to or bracket a to infinity are also used when you want to include endpoints. So what we're saying here is this is just representing the inequality that x would have to be less than or equal to a, and this is representing that x would have to be greater than or equal to a. So I'd like to point out here that when you do go to infinity, we are going to always use parentheses for those cases because you never can actually reach infinity, kind of like when you have a strictly less than inequality or strictly greater than, like you have here and here. We don't ever actually reach that a. So that's why we have a parenthesis. Well, the same thing with infinity, you don't actually ever reach it, so you're going to use a parenthesis again. So we're always open at infinity. So just a list of inequalities here and their interval notation. So if both sides are a strict inequality, well, then we use parentheses. If we have both sides of x are going to be a inequality with an equal or a, a less than or equal to sign, there we go, then we're going to use brackets. If the first side is strictly open, but then the second side is inclusive, then we have a parenthesis, then a bracket. If the first part is inclusive, but the second part is a strict inequality, then we have bracket parentheses. If we're just strictly less than, then it's negative infinity up to that number. If we are less than or equal to, is negative infinity up that number with a bracket. If x is greater than, then we're going to have a greater than to infinity with all parentheses. And if x is greater than or equal to, then we have a bracket to infinity, and then we use parentheses. And another thing to note here is we always write this as smallest first, and then the largest number second. This a should always be smaller than this b. That should be the case in all of these. So for an example, we want to write these following inequalities in interval notation. The first thing we do is 3 is the smallest, so we'd write 3 first. 8 is the largest, so we'd write 8 second. So right at 3, we have a strictly less than inequality, so we use a parenthesis. 8, we have a strictly less than inequality, we use parenthesis again. So x, such that x is greater than 3 but less than 8, is parentheses 3, 8, parentheses. For b, we have x is greater than or equal to 4. So the smallest possible thing that x can be in this case is x is everything greater than 4, so at smallest it is 4. And at greatest, I don't have a cap, so it goes towards infinity. Because we have just this inequality, well, infinity is always going to be a parenthesis, but x is greater than or equal to 4, we use a bracket after 4. So for your worksheet, give you 3 more inequalities. So just take a moment and try to write these in interval notation. Right, so for A, x is between -2 and 9. -2 is the smallest, so it goes first. 9 is largest, it goes second. We see at the -2, we have a less than or equal to, so we use a bracket at -2. On the side with the 9, we see a less than sign, so we use a parenthesis. So -2 less than or equal to x, which is less than 9, is the same thing as saying bracket -2 comma 9 parentheses. So for b, we have x is less than, strictly less than -2. So at most, x could be -2. That is the largest. So anything smaller than that, so we have to head towards negative infinity. So if that's negative infinity or any kind of infinity, it's a parenthesis. And on this side, because we got that strictly less than at -2, this is also a parenthesis. So x is less than -2 is the same as parentheses, negative infinity to -2 parentheses. And then for C, x is between -100 and 100. And at both sides, I have a less than or equal to, so we'd have a bracket of both sides. And make sure negative infinity is first, and negative 100 first, and positive 100 second.